In this video, we'll solve this problem. 100 ml of water at 90 degrees centigrade and 200 ml of water at 60 degrees centigrade are mixed. What is the temperature of the mixture? This is the question given. Now let us solve this problem. First, let us write down the information given in the question. First, let us write about hot water. The mass of hot water m hot is equal to 100 ml and the temperature small t, let us write it down as, is equal to 90 degrees centigrade. Since it is hot, let us write down H here. And let us write down for cold water. For cold water, m cold is equal to 200 ml and T cold or Tc is equal to 60 degrees centigrade. Now let us understand this problem. When a water at a more temperature is mixed with water at less temperature, you will get a temperature which is in between both the temperatures. That is called equilibrium. Now let us write down what equilibrium means. We know that heat lost by hot body will be equal to the heat gained by cold body. Assuming that energy is not lost to the surroundings, we can write Q hot, that means heat lost by hot body is equal to Q cold, that is heat gained by the cold body. Now we know that Q is equal to ms delta T, where m is the mass of the body, s is its specific heat and delta T is the temperature difference attained due to the heat. Here instead of QH, we will write down the values of mH, S and delta T. Let the equilibrium temperature which is obtained be capital T. Capital T indicates the temperature in Kelvin. So let us convert the T hot and T cold also into Kelvin. So we are converting the temperature into Kelvins. Therefore, I will be writing capital T hot is equal to small t hot plus 273 Kelvin. So, I will be getting 90 plus 273 which is equal to 363 Kelvin. Okay, now let us write the cold temperature T cold which is in Kelvin. So, small Tc plus 273. This is equal to 60 plus 273 which is equal to 333 Kelvin. Now let us use these values m, t and s and then find out the equilibrium temperature. Q hot, I am writing it. Q hot is mH, S, delta T. Instead of delta T, I can write TH minus capital T. So I will substitute the values of mH. It is 100 ml. So 100 ml into S is same for both hot and cold water. Because it is water, the specific heat of a particular substance is always constant. Both of them are water. Therefore, the S remains same into S into what is the value of TH? It is 363 Kelvin. Therefore, 363 Kelvin minus capital T. Now let us write down for QC. QC is equal to MC into S into T minus Tc. Let us substitute the values of MC and Tc. The value of MC or mass of cold water is equal to 200 ml. Therefore, 200 into S into T minus Tc value is 333 Kelvin. Therefore, I will be writing 333 here. Now, since we are assuming that the energy is not lost to the surroundings, heat lost by the hot water will be equal to the heat gained by the cold water. Therefore, this 100 into S into 363 minus T is equal to 200 into S into T minus 333. I can cancel S on both the sides because it is same. I will be cancelling 2 zeros here and 2 zeros here. So I am left out with 1 into 363 minus T. So I will be getting 363 minus T only is equal to 2 into T minus 333. Now let us solve this one. 363 minus T is equal to 2T minus 666. I'll be bringing T terms onto one side and constants onto other side. Then I'll be getting, so 2T minus T is equal to 666 minus 363. So T is equal to 6 minus 3 is 3. 6 minus 6 is 0 and 6 minus 3 is 3. So I got 303 Kelvin. Now I have to convert it into degrees centigrade. What is the thing I have to do? I have to subtract 273 from it. Then I will be getting the temperature in degrees centigrade. So small t or the temperature of the mixture is equal to 303 minus 273. So 3 minus 3 is equal to 0. Since 0 is there, I will be getting 1 as borrow. So 10 minus 7 is 3 and this is 2. 2 minus 2 is 0. So I got 30. That means the equilibrium temperature or the temperature of the mixture when both the cold water and hot water are mixed is 30 degrees centigrade. In the next video, we will see more problems related to specific heat.